Example 4, we have the difference between independent and dependent events. In part A, it says, suppose the probability of A is 0.39, the probability of B is 0.35, and the probability of B given A is 0.2. We need to find the probability of A and B, and then the probability of A or B. So to find the probability of A and B, we need to use our multiplication rule, the probability of A times the probability of B given A. So when I replace the probability of A with 0.39, and I multiply it by the probability of B given A, which is 0.2, I get 0.078. Now I need to find the probability of A or B. Our formula for finding A or B is the probability of A plus the probability of B minus the probability of A and B, where we subtract off anything that they have in common so we don't double count. We know that the probability of A is 0.39. We know the probability of B is 0.35. And then we weren't given the probability of A and B, but we just figured it out. It's 0.078. So now when we combine that all together, we get that the probability of A or B is 0.662. Now, let's look at part B. In this part, we're saying, let's assume A and B are independent. So that gives us a little bit more information. We have that the probability of B is 0.35, the probability of A given B is 0.32, and we need to find the probability of A, the probability of B given A, and the probability of A and B. Now, because we know that events A and B are independent, that tells us that we know that the probability of A given B is the same thing as the probability of A, because whether or not we assume B is true, it's not going to affect our probability of A. So those two values are going to be the same. We also know, reversing the letters, that if we find the probability of B given A, that's the same thing as the probability of B. We know this because A and B are independent. So when we need to find the probability of A, since I know that's the same as the probability of A given B, I know that it's equal to 0.32 that's given in the problem. When we need to find the probability of B given A, I know that that's the same as the probability of B, and we're given that in the problem, which is 0.35. Now, to find the probability of A and B, normally we would take the probability of A and multiply it by the probability of B given A has occurred. But because I know that this is equivalent to the probability of B, all I have to do is multiply the probability of A times the probability of B. So that gives me 0.32 times 0.35, and we get 0.112. So when you see information like this in one of your homework questions, don't ignore it because that's giving you more information.